Hello everyone, and welcome back to the Kohi Game Engine series. Today we're going to talk about render passes, specifically the configuration of render passes, and render targets. So before we jump into the video, I would like to take a quick minute and thank the partners of the channel. The partners are the highest tier support both on YouTube and Patreon, and they are Caden, Eearslya, Gerboles Inc., Super Awesome, and Wensheng. I'd also like to thank all the other fine folks that appear on the screen here. Your support is greatly appreciated. Thank you very much. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. Okay, so let's go ahead and get everything started up here. So dev Kohi and code. And we're going to do a couple of minor house cleaning items first. So one of the things that we currently have is, if we just do a clean and a build on this real quick, one of the current things that's kind of bothering me a little bit is our camera startup position. So when we actually start up the application, our camera is sort of facing a wall to begin with, and that's kind of annoying, right? So I'd like to get a better starting position so we can kind of, start over here somewhere. That's a little bit better. So I want to go ahead and change the camera's start position first. So I'm actually going to set that to, we'll go with 10.5F, and I've already kind of figured this out ahead of time, so I don't have to do it on camera. And then 5.0F, and then 9.5F, right? So this is just a little bit better of a starting position so that we don't have to move the camera every single time to see the scene properly. So let's just go ahead and have a look at that. And that's much better. That's a much better starting position. We can kind of see the scene, a little bit of our lighting here. And we can very easily and quickly see what's going on. Okay, so this time we're going to talk about a couple of things. We're going to talk about predominantly configurable render passes and render targets. Now, we've already discussed what render passes are, so we're not really going to be changing render passes all that much. We're really just going to be making them configurable. And this is all leading up to our view system, because we eventually want to be able to configure our render passes to be hooked to a view. And in order to be able to configure a view, we need to be able to configure the render pass. So that's part of that. And then we're going to have something else called render targets. And a render target really is nothing more than a texture, but it is also going to be a frame buffer. So whenever you render to a texture, or treat that texture as a render target, typically that's also going to have a frame buffer associated with that. So whenever we set an active render target, we are essentially talking about a texture and a frame buffer. So we're going to create a structure that contains both of those things for convenience, and that will also allow us to configure things later on. So before we jump into that, however, there are a couple of changes that I would like to go ahead and make. So one of the things that we have right now is we have our frame buffers, our render passes, sorry, in a different file. And one of the things that I want to start doing is I'm trying to, sort of bring everything together in one single backend file so that we don't have so many files all over the place. And so as we go with this, I'm probably going to be combining several pieces of this backend into our Vulkan backend.c. So one of the first things that we want to do is actually take this render pass stuff and move it out of this file. If you guys are following along, this is technically optional, but I find that it kind of cleans things up a little bit. And it's one less include that we have to include in various places, and it just sort of will increase our compile efficiency and things like that. So there are going to be some of these things that we're not going to move, but render passes is one of the things that we are going to move. So what I think I'm going to do is I'm going to go ahead and take everything out of our H file here. So we have our render pass clear flags. Let's go ahead and move that first. So that we're actually just going to move into Vulkan types. So I guess I can put that probably right above the render pass state. Should be sufficient. So let's go ahead and just put that there. That should be fine. And then we'll come back and we will take, whoops, I forgot the comment. Let me move that too. Okay. Let's go back to our render pass and we will grab our function definitions and we will move them as well. I'm actually thinking to first the Vulkan backend.h. And actually, let's go ahead and we will put this at the bottom here. And the other thing that I'm going to do is this Vulkan backend.h has sort of a lot of comments in here, documentation comments. And these mirror directly what is actually in the interface. So in order to make this file a little bit smaller, I don't feel that we need these specific comments here. So I'm actually going to get rid of all these. Again, this is optional. You guys don't have to do this. But since this pipes directly into the interface, it's not really all that important for us to have all this documentation because we never actually see this in IntelliSense or anything else. The only place these are actually explicitly called is in our backend.c, or renderer backend.c rather. And so we really don't need to have all these comments in here. So I'm just going to go ahead and clean this up real quick. And we got a couple more. So here's our render pass create, our render pass destroy, and our render pass begin. And these, if you recall, are already actually hooked up in the renderer backend.c. So we're not actually going to have to do too much to that file. We're really just going to be removing a include. So now we can go into our C file, and I believe we can grab everything here, except we don't need these includes at the top, so I won't grab those. But I will grab everything else out of here, and we'll go into the back end, and we'll go all the way to the bottom, and paste those in there. And I'm not going to bother renaming them or anything. I think I'm just going to keep them as is for now. And now we can delete our Vulkan renderpass.c and our Vulkan renderpass.h. And let's see, we need to do our renderer backend because that is, at least I thought it was. Did we not actually expose this to the front end? We might not have. I don't think we did. So that is actually something we're going to have to do. I had thought we'd already exposed that to the front end, but we apparently have not. So that is also part of the reason for this move. I had forgotten that we had not actually exposed that. So we need to go ahead and do that. So I guess the first thing that we're going to want to do is probably go ahead to the Vulkan, sorry, not the Vulkan, but the renderer types INL. Because we are actually going to have to come in here to our renderer backend struct and add these definitions. So the definitions for that, let's see. Do I actually have this so I can just copy pasta it? Because I really don't want to redo all of this from scratch. I don't think that I do. So what we're going to need to do is we're going to need to create a new function pointer. Let's see, how do I want to do this? All right, so we actually will have a new structure, because right now we only have, I believe, just the Vulkan render pass, but I don't believe we actually have a generic render pass structure. So let me see. We have built-in render pass, which these are going to be going away. And we have, yeah, we're using render pass ID. That's what I thought. So basically what we're going to do is we're going to make this a little bit generic in that we are going to have a new render pass structure, and we're going to deal with pointers of that instead of actually dealing with individual render passes by ID. So I think probably the best place to start versus adding our definitions here is probably going to wind up being declaring those types itself. So in renderer types, there are a bunch of things that I am going to want to go ahead and configure and set up. So I think the first thing that we're going to do is we're going to start with a generic structure for render passes. And I'm actually thinking probably the best place for this is going to be, we're going to need it to be above this structure. So right above the structure, I think is where I'm going to put all this stuff. So right above our renderer backend, let me just maximize this, get rid of this so we can see what we're doing. We're going to have a new structure called render pass. So this will have an ID so that we can look that up by ID if we want to. We're also going to have a render area, a clear color. So these are things that are already kind of associated with our backend render pass or our Vulkan render pass. And then we're going to have our clear flags, which we've already kind of set up before. We're also going to have a render target count. And this is going to be equivalent to our swap chain images for right now. So right now we have actually 3 of those for our UI and our world render passes. And so this will wind up being 3. And then we have a new structure here called render target, and it's going to be an array of those. And I'll come back to that in a second. And then we have our internal data, and this is where we're going to store our Vulkan render pass. So along with the render pass itself, we have a configuration object. So that just takes the application name itself. And oops, that is the render backend config. Sorry, misspoke there. So we're also going to have to configure the backend, and I forgot that that's actually a step that we're going to have to do. But the backend basically is going to have to take a set of these render pass configurations. So we have a render pass count, an array of render pass configurations, and then a callback that's going to be made when a refresh is necessary for the render target. So we're going to cover all of that in this video. I know it's kind of nebulous at this point, but I promise all the pieces are going to come together. So we have a renderer backend config, which takes in our render pass configs. Our render pass config actually goes above the render pass, so we can actually paste that in here. And that basically is just the name of a render pass, the name of a previous render pass, if there is one, the name of the next render pass, if there is one, the render area and the color, and then clear flags. So these things will be used to construct one of these render pass objects. And then we will basically essentially create these render pass configs, probably either in the application or the renderer front end. I haven't really decided yet. And then we will jam those into a renderer backend config where we go ahead and stand that up. Okay, so I hope that has made sense so far. We've already moved our clear flags, so that should not be an issue. Actually, did we place that? Did we place that? Yeah, this was actually placed in the wrong spot. So this actually, these flags are actually not Vulkan specific. And up until now, they have been sort of in our Vulkan files, but actually these should not go in our Vulkan types. These should go in our renderer types. So let me go ahead and put that here, just above our configuration. Okay, so the last thing that we're going to need to create is a render target structure. And we've sort of touched on this a little bit, but there's not a whole heck of a lot to this structure, thankfully. It's actually really relatively simple. So we have an attachment count, which is the number of attachments or images or pointers to textures, right? Our attachments themselves are just pointers to textures. So these would be our wrapped swap chain images. And so when we create our render target, we will be pointing to those. This is a double pointer because it's an array of pointers. And then we also have a void pointer to an internal Framebuffer object. So the Framebuffer is not something that we need to render or represent rather on the front end. We only really need a back-end representation of that. So when we go ahead and stand up the Framebuffer, we can just treat that as an internal void pointer, and we can just create that at that level. And we should not really need to create that outside of the renderer backend. Okay, so the other thing is we have a Boolean here as to whether or not we want to sync to the window size. So whenever there are window resize events, do we want to also call resize on the texture? And we may or may not implement that right away because that's kind of automatically already happening for us. But it is something that eventually I want to hook up, so I've put it in here for now. Okay, so that is all of our structures that we're going to need, at least all of our new structures. So it seems like a lot, but I promise it's actually not as much as it actually looks like it is. One thing is, I did mention that we also do not want to be dealing with these built-in render pass things anymore. These were supposed to be temporary, and they are in fact temporary. So we had these sort of IDs for built-in render pass world UI, and we don't have to want to have to add to an enum every single time that we are actually trying to add a new render pass. That's stupid, right? So this was just something to kind of get us up and running. We can actually nuke that now. We no longer need it. So that does it for all of those updates. The next thing that we're going to have to do is we're going to have to set up some new functions in our structure. So we have our renderer backend structure here. And the first thing that we're going to need to do is change the initialize. So right now it just takes the renderer backend and then the application name. And this is not going to be quite enough information because we're actually going to need a full-blown renderer configuration now. And so what we're going to do is we are going to paste in a render target config. So this is going to be a constant pointer to that. So we'll create that in the front end and pass it through. And then we're also going to have a pointer to how many window render target counts we have. And so what this is going to represent is how many of the individual configurations we're going to have to create, specifically this right here. So when we set up a render pass, if we're setting up a render pass that deals with the Windows render target specific, we are going to need to know what this count should be. So when we initialize this system, it is going to tell us how many of those things that we have. So if we're triple buffering, it'll be 3. If we're just double buffering, it'll be 2. Okay, so that is that. And along with that, we actually need a couple of just small updates to our comments so that it's clear as to what is going on. So we'll just put in there config and out window render target count and delete that application name. Okay, so shutdown doesn't really change at all, so we don't really need to worry about that. Begin frame, end frame, none of that stuff changes. However, now we have this begin render pass, and we were using a render pass ID. That is now no longer correct. So what we actually want to do is we want to pass a render pass object along with a render target. And this will allow us to have a little bit of flexibility because render passes aren't necessarily always going to be rendering to the same render target. We could have, basically we could reuse the same render pass, but have it work against different targets potentially. So we want the flexibility to be able to do that. So we're going to pass the render pass and then which specific render target it's actually going to be operating against. And so the easiest example of this is we need the render target for the current frame being rendered to in Vulkan. And so we need that flexibility to be able to say, hey, we want to use this render pass, but against this render target. So with that, we are actually going to be getting rid of this render pass ID and replacing it with pass and target. And then end render pass is simply just going to take a render pass pointer instead of the ID. So really all this is going to be is instead of render pass ID, this is going to just be pass, and it's going to be, it's going to be a pointer to the render pass to end. All right, and next we are going to have a new function that we are going to call render pass get. And we are going to be able to get that by name because the render pass will ultimately be stored in the back end. So if we need a pointer to a render pass, that's where we're going to actually have to get it. So if you recall, the render pass configuration is created on the front end and passed to the back end. The back end is actually what creates that render pass still. So that's not actually changing. It's just if we need a pointer to that, this is our way to go ahead and obtain that. So the next thing that we need to do is in our shader create, we actually have a reference here to a render pass ID. This is obviously no longer going to be correct. So we need to change this to be a render pass. And that's going to obviously be a pointer to a render pass. So we'll just call this pass, a pointer to the render pass to be associated with the shader. So we're now going to use a proper render pass for that. And then we're going to go ahead and create some new functions within our backend structure. So we can come down here to the end, and right after we have our map release resources, we'll go ahead and add one for render target create. So this is just for us to be able to create a render target. Now, obviously, since we have a create, we need a destroy. So there is that. So we'll go into the implementation of each one of these functions as we get there, but I'm just trying to cover the high level stuff for now. So next we have, so our render target create and our render target destroy are there. Now we have our render pass create and our render pass destroy. So as you might expect, we have a pointer to the out render pass. We take the depth stencil, has previous, has next on our render pass create. Our render pass destroy, we just pass a pointer to that. Next, we have this concept of attachments for our render targets, but we need a way to actually be able to obtain the attachments that were created or the textures that were created or wrapped around those swap chain images. So we need a generic way to do that. So what we have here is a window attachment get, and this returns the attachments that are specifically used for rendering to the window, aka the swap chain images. And so this will just return the one at the appropriate index, and it returns the texture pointer or the wrapped texture for that particular attachment. We also are going to need to make a change to do the same thing for the depth attachment. So right now the depth attachment is still a Vulkan image, I believe. So we're actually going to need to change that to be a wrapped texture as well. And this is basically just to get that attachment. And then finally, we have here a window attachment index get. And this is ultimately going to return our swap chain image index in the terms of Vulkan. But for other render APIs, this may just return either 0 or 1, something like that. And so this is what we're going to use. This returned index here is what we'll wind up using when we go ahead and retrieve either a pointer to the individual attachment, or when we're going ahead and calling our render to activate a what's the word I'm looking for? To render against a specific render target. Okay. Anyway, so it's a lot of structural changes to our render types, and thankfully, a lot of this is just sort of replumbing the backend to be a little bit more aware of all of these things. So the next thing that we're going to want to do is we're actually going to want to go into our Vulkan backend, H, and we're going to need to make a few adjustments here. So I think I'm probably just going to do this sort of in chronological order. So we have our, let's see, our render pass create. So that just takes in all of this. I think that actually should be fine. I don't actually think. Let me check. Did we actually change our initialize yet? No, we have not. So actually, that's probably the first place we should start. So our Vulkan render backend initialize, that now needs a const pointer to a renderer backend config, and we'll just call that config. And then it also needs a U8 pointer to hold the out window render target count. So that is updated to match our renderer types definition here. So we have that. And then I believe everything is all good until we get to render passes. So we have our begin render pass here. So that takes a render pass ID. We no longer want to do that. We want a render pass pointer that we'll call pass. So we have that, and then we also want our render target, and we'll just call this target. And so we take pointers to those things. We also, to end a render pass, we take a pointer to the render pass as well. We also are going to need our render pass get from the back end, so that is going to go right there. And that basically just takes in a name and returns a pointer to a render pass. Let's see. Also, our shader create is going to need a pointer to a pass, so I'm actually just going to copy that. And we have our shader create here. Instead of a render pass ID, we are going to take in a render pass pointer. And then finally, we have all of our definitions for our new functions that we're going to be adding. So I'm going to go ahead and just put this, I guess, right here at the end. Makes probably the most sense, I'm thinking. So we have our render pass create, our render pass destroy. We have our render pass end and our render pass begin. Yeah, I guess what we can do is we will just put our render, Vulkan renderer, render, target, create, and destroy methods. We'll put those at the very end here. And then we'll also go ahead and slam in our new functions for our attachments here. So we'll have our Vulkan renderer window attachment get for a particular index, and then our depth attachment get. And then our window attachment index get. We'll put all those things at the end. I think that makes the most sense. And I don't think I missed anything. I think that is all we should need to do at that level. So what I'm actually going to do is I'm going to copy these and go to the backend C, go all the way to the bottom, and just paste in our definitions so that we can fill them out later. And actually, let me close that side window so we can see what we're doing. Okay, so that is all of our definitions for that added. I believe that is everything that we need, at least for right now. Let me double check. So we have our begin render pass, our end render pass. Do we have our render pass get? I don't think I added that. So let's go ahead and add this right here next to these functions here. We have our begin, and we'll go ahead and put our get here, because I don't think, no, we didn't have that. So we'll need to also add our render pass get. Let's go ahead and just browse to this function, and we'll put it right after that. So that winds up being at the end as well. All right, so that is predominantly the changes that we need to make for the H file. Now, the C file is probably going to be the largest amount of changes that we're going to need to make. So let's go ahead and knock this out, and then we'll bubble all this stuff up to the front end and go from there. So the first thing that we're going to need to do is, since we have already deleted the Vulkan renderpass.h, I think we got rid of that, right? Yes, we did. Okay, so since we got rid of that, obviously we shouldn't be including it. And our application.h, I don't think we're actually using this anywhere, so I'm going to go ahead and remove that as well, because I don't think we actually need it. And another thing I'm going to do is our cached frame buffer width and height. I'm going to go ahead and get rid of those, because we're actually going to be changing up the way that that works. Next, we have our regenerate frame buffers. That is going to wind up going away as well. So go ahead and get rid of that, because that is sort of done for us right now automatically as part of the Vulkan renderer, but it's not something that needs to work that way going forward. So we're going to change that. Skip past upload data range. The next thing we'll need to change is the initialize. So instead of application name, now we are going to take a renderer backend config pointer. That should be a constant pointer. And we're just going to call that config, and a U8 pointer called out window render target count. All right, and we'll fill those things out as we continue. So the reason we had application in here was because of application get frame buffer size. We're not actually going to be doing this anymore, so I'm going to go ahead and get rid of that. We're going to be refactoring that as well. And instead, what we're going to do is we're going to say context dot on. Whoops, did we not actually add that yet? I don't think we did. So we actually need one more change to, let's see, that's going to be, I actually forgot a level of updates that we're going to need to do first. So we're going to break on this, go to our Vulkan types. There are actually a series of changes we're going to need to do here as well. So one thing that we're going to need straight away is in our Vulkan device, we have our depth format here. Since we're going to be wrapping this, we actually need a channel count for our depth texture. So we're going to need to go ahead and store that. And that's just so that we can wrap that. The Vulkan render pass itself is now no longer going to hold the render area or render color, clear color rather. Those are held by the sort of front end representation of that, so we no longer need that. The same is true for our clear flags. So we're going to go ahead and delete that as well. And then we're going to need to go to our swap chain. So we want that. And our depth attachment, as I mentioned before, is, where is it? Here we go. I guess I was on the wrong structure. Our depth attachment right now is a Vulkan image. This should be a texture pointer. if I could spell. So that should be a texture pointer instead, and this should be the depth texture. So we're going to wrap that as well. Okay, so the next thing we have is our VK frame buffers being held in the swap chain. That is no longer going to be what we're going to use directly there. We are instead going to use our render targets for this. So this is where those render targets will actually live for the swap chain. So we're going to have 3 of those, just like we did for our frame buffers, right? And those will contain our frame buffers. The next thing that we want to do is probably, I'm thinking, right ahead of the Vulkan context. Vulkan context. Next one. Whoops. Okay. Wow, Vulkan context is not wanting to... Search is just not wanting to work for me for some reason. All right. I'll find it in here the hard way. Here it is. Okay, so right above this, we're actually going to want to have a max registered render passes because we're going to have an array of our render passes stored. We're starting off with 31, just so that it's a first off, it's a prime number, which is always good because we're going to be keeping these in a hash table for name lookups. So we're going to start off with 31 of these. I don't know. That may not be enough. We might have to increase that to a larger number once we actually get going. But for now, we're only going to have a few render passes. So I don't really think it's going to wind up being that big of a deal. But anyway, so we're going to need a couple of changes to our context, as you might have guessed. So we have our Vulkan render passes here. These are going to be changing. But first, right below the swap chain, we want to go ahead and create a hash table for our render passes to be stored in. And then obviously a block of memory for that. And then instead of having the sort of hard-coded UI and main render passes, we are going to have an array of registered render passes. And this is going to be that max render passes amount. So this table is just going to store indices into this array here. Okay. All right, and then a couple more things. So instead of dealing with our frame buffers, which is here, and these are used for world rendering for right now, and we're going to kind of stick with that name for right now. This eventually is going to wind up being changed, but for right now, we're just going to call it world render targets. Because we are still actually using that for a world render pass. I'm not really happy with the name all that much, but I also don't have a better alternative at the moment. So we have that, and then finally, all the way down here, we're going to be adding one more function pointer, which is on render target refresh required. And so this is a quick way for us to be able to assign a function pointer to say, hey, whenever we resize the window, for example, we're going to need to refresh our render targets. So we have all that. And that is basically all the changes that we need to make to Vulkan types. So I should have done that first, but you know, it happens. All right, so now the Vulkan backend is probably I guess the next thing that I could wind up changing. I wonder if I should do maybe the swap chain stuff first before we jump into that, because that might be a little bit quicker to get through. In fact, actually, let's do a couple of other smaller things first. Let's just knock out the low-hanging fruit. So I want Vulkan device.c. We're going to have to change just a couple minor things in here. So we changed the depth texture to be an actual texture instead of just an image now. So what we're going to need is when we're selecting, or detecting rather, our detect depth format, when we're doing this, we're also going to need to store a channel count that aligns with these things. So in these two cases, it's going to be 4, and in this third case, it's going to be 3. So we just need to store that because we're going to need to know that when creating an actual texture. So we have our sizes here, which is 4, 4, and 3, 4, 4, 3. Okay, see how that lines up? And then all we're going to do is we are going to come down here, and in our, when we're doing these calculations here to detect the format, we are going to say the device depth channel count is equal to the sizes at sub I. So as we're finding one of these things, we're just going to set the depth channel count appropriately. We also need to do that here. So that way, when we go to wrap the texture afterwards, using this detect depth format, this information that we require is already set. So just a small change there to Vulkan device, but one we need nevertheless. All right, probably let's go ahead and knock out the swap chain changes next. So swap chain. So there's just a couple small changes in here that we're going to have to make. So I guess we'll go ahead and go to create. And the first thing that we have here is, let's see, where is the image create? This is probably going to be a little bit further down. Image create, here we go. Okay, so right now we have this Vulkan image create, and this is essentially writing directly to depth attachment, which is actually not what we want. So what we're going to do in the meantime, at least for now, is instead of doing that, we are going to allocate some space for a new Vulkan image, and instead of passing directly to this, we are going to wind up actually passing image instead. So instead of doing depth attachment, we're going to do image. And then, let's see, so the image has been created at that point. And the next thing that we're going to need to do is wrap it in a texture, as we've sort of discussed before. So all we're going to do is say our swap chain depth texture, which, why is it saying, didn't we already change this? I thought we did. Did we not? Oh wait, why did it take me to context? I don't want context. Swap chain. Oh, right, okay. Depth attachment is, oh, because I just changed that to texture, that should be also renamed to depth texture. There we go, okay. So we're setting our depth texture to texture system wrap internal, and we're basically going to name it just underscore Kohi default depth texture, so that there's very little chance of us actually colliding with that as far as names are concerned. And so we're passing it that required channel count that we had before. And then as far as these booleans here, we have whether or not it has transparency, whether it's writable, and whether or not it should be registered. So it does not have transparency. It is writable, but we should not be registering it so that we cannot do texture lookups against it. And then we, of course, pass the internal data, which is the image that was created here. So since we are actually allocating for this up here, that means down here in destroy, we're actually going to have to handle this as well. So instead of just calling our Vulkan image destroy here, we're actually going to need to change this from depth attachment to swap chain depth texture, and we'll do internal data to that. Whoops. And that's also going to have to be cast to a Vulkan image, just to be safe. Vulkan image pointer, rather. And then we're going to need to do k-free, and we're going to pass the swap chain depth texture internal data, and that's going to be the size of a Vulkan image, and it is going to use the memory tag texture. And then we'll go ahead and zero out that internal data too. So let's go ahead and just grab this and set that to 0. That way we don't leak any memory. So that is just the small set of changes that we need to make to our swap chain. So let's see, are there any other things that we should probably knock out sooner? Let's go ahead and no, I guess all that stuff's for the front end. I'm just reviewing my notes here to have a look at all the stuff that we have to change because it's quite a long list. So, I think though, the back end is probably going to be the next thing that we need to do because everything else is sort of bubbling it up to the front end. So let's go ahead and do that. We'll handle the back end. All right, so, oops, we want the backend C file. All right, so I believe the next thing that we were doing is we were actually going to assign the, where was that? The on render target refresh required. So we're going to assign that function pointer to the one that is provided in our config. So that's going to be on render target refresh required. So that way, whenever we require a refresh, which the front end will notify us of, that connection is made there. All right, and then we're going to go ahead and set in our context a default frame buffer width and height. And we're just going to roll with these for now. We're not going to use the cached ones anymore. It was kind of an extra step that's no longer really necessary, so we're just going to do this instead. Next, we have our application name, which is now config application name. So that's got to be updated. The next thing that we are going to do is come down here to where we're creating our render passes. And this is, let's see, where is, here we go. So we're creating our render passes here. So we have our UI and our world render pass. So we're no longer going to be doing that manually. We are actually going to, we're going to be doing that using our configuration. So the first thing that we're going to do, however, before we do that is we are going to save off the number of images that we have as the number of render targets we need. So here we have our swap chain image count. That is what we're going to use and set to the value pointed to by our out window render target count. And then what we're going to do is we are going to hold our registered render passes. So the first thing that we're going to do is we're going to invalidate all entries in the registered render passes array by setting their IDs to invalid U16. You guys have seen that stuff before, so I'm not really going to go over it too much. So the next thing that we're going to do is we're going to set up the hash table. So that's just allocating some memory for the hash table block, setting up our hash table. Again, this is all stuff that you guys have seen before, so I'm not really going to go into that too much. But now we are going to go ahead and loop through our render pass configuration. So we have our render pass config count, and that is probably going to wind up being something that we're going to want to move this to a function. But for now, I'm going to do it in line, but I am going to put a to-do here. And make sure that we don't have... well, first off, we probably ought to move this to a function. I'm just going to do it in line. And then second, we are going to make sure that there are no collisions with the name first. We probably... we shouldn't really have any of that unless we configure something where render passes are named the same thing, but we shouldn't ever really run into that, right? So we're going to make sure that we don't run into that, but all we need to do for that is simply say, okay, well, let's try a hash table get using the render pass table. We will pass the current configuration's name and output to an ID. If that ID is invalid ID, or if it's not invalid ID, in other words, one has been registered, then we're going to go ahead and bleat about that and fail the renderer. We're not even going to allow it to start up if we have a name collision. Otherwise, we're going to go ahead and snip up a new ID. Again, this is all stuff that we have seen before. We will go ahead and make sure that that ID was actually gotten, that we had a free space for that. If not, we're going to bleat about it. And then what we'll do is we will set up the render pass. So all this is going to do is set up the clear flags, the clear color, and the render area. Copy those over from the individual config. And from there, we will go ahead and call our Vulkan render pass create. So from here, we are going to go ahead and pass, whoops. So from here, we're going to go ahead and pass the render passes ID. Why are we getting error types on these things? Did we forget and include somewhere? Oh, I think we actually need to make some updates to this Vulkan render pass create. Yes. Let's see. So we have our context, which is still required there. We actually don't need that anymore, so I think that's the problem. So our Vulkan render pass create is taking in a context right now, which we don't need anymore because we've moved this to the Vulkan backend C. So I'm thinking we should actually be able to remove that. So our Vulkan render pass create, and actually destroy doesn't need the context either. So we can go ahead and get rid of that. Let's come back here to the C, go down to the destroy, and get rid of that. Okay, and that's going to cause some errors, but we'll come back to that. The main point is we should now be relatively good. Let's see, out render pass. Let's see, why is this? So we have a render pass type here. Why is that saying error type? Oh, because this actually needs to be just a generic render pass now. Right, so this function is going to be changing. So actually this should just be render pass. Let's actually change this to pass. And this should be just render pass. And okay. All right, so we'll come back to refactoring that, but now our call up here at the top should be mostly correct. Why is this bleating now? So we have our render area. You know what? I'm going to come back to this because we're going to have to refactor this. So let's just do that in a separate step. But basically what we're going to do is we're going to create our render pass and then update the hash table record. So once we actually update this, this function to be what it needs to be, these errors will go away. So we'll come back to that. Anyway, so what we do here, just to recap, is we are setting up each of our render passes according to the configuration. So we create it and set the found ID in the hash table, and then we can look it up later. Okay, so we have our initialization there. The next thing that we're going to need to do is perform the changes for the shutdown. So this is going to be, let's see, our render passes. Here we go. So we have our destroy frame buffers here. This is no longer going to be that. It's going to be render targets. So anywhere where we have frame buffers right now, it's always going to be render targets going forward. And then so instead of calling vk destroy frame buffer, we are actually going to call render target destroy. We do not need to pass the device. We're going to call this world render targets. Whoops. Render targets sub I. We do not need the allocator. However, we do want to free the internal memory. Again, we haven't gotten to the implementation of these yet, so I will explain that later. Context. This should be... Oh, we need the... I think we need a pointer. Yeah, that's... Okay, so we need the address of that. So it should be the address of context, world render targets for there, and then the address of context swap chain render targets sub I, and then this should be true for destroy internal. I think that's right. I think this is, the code is so broken right now, I think VS Code's actually having trouble keeping up with the changes. All right, so we have our Vulkan render target destroy, so we've got that done. We need to destroy our render passes, so instead of this, we are now going to have just a simple loop, a U32, I equals 0, I is less than Vulkan max registered render passes plus I. Simple stuff. And then we're going to say if context dot registered passes sub I dot ID is not equal to invalid ID, U16, because that's a U16. Then we're going to say Vulkan render pass destroy. And we're going to pass the address of context registered passes sub I. And that will destroy our render passes. So that's no longer hard-coded. All right, the next thing is we need to, let me just build this. I know it's going to scream at me, but all these errors are driving me nuts. All right, so on our resize, we have our cached frame buffer width and height. So this just needs to be called change to context frame buffer width and height. And that should eliminate that. Let's see. So the next thing is actually going to be in our begin frame. We are doing a couple things here that we need to update. So first off, we have the render pass dimensions that we're doing here. We're updating the render pass dimensions. We're not going to be doing this anymore. This may wind up causing issues with resizing down the road, but for now, I'm going to leave that as is and just delete it. So we don't need to be doing that anymore. Nothing to do in end frame. Begin render pass, instead of that, is going to be changed to our new signature. So we're going to have render pass pointer. We'll just call this pass, and then render target pointer target. And then thankfully, we can actually get rid of this switch. So we have this switch here on render pass world and UI. We no longer need that. In fact, we no longer need this because Vulkan render pass is not what we're going to be using there anymore. So we can get rid of that. We still need the command buffer. Let's get rid of this switch. We don't need that anymore. And instead, we should just be able to go ahead and, let's see, Vulkan render pass begin. I'm actually thinking we just have this Vulkan render pass begin, which performs all of this. And I'm actually thinking that since we already are since we have Vulkan render begin render pass, we don't need that and a render pass begin. So I'm actually going to completely remove this function because I don't actually believe that we need it. So I'm just going to nuke this. And I'm going to go ahead and nuke render pass end as well, because we're actually not going to need that because we can just do it in line. We don't need multiple levels of that. So we have our render pass begin and our render pass end. Oops. Yeah, and we already have begin and end up here. So we don't need these second versions at all. So we can actually get rid of these. So because we've moved those away from being in the separate file, we don't need those at all anymore. Okay, so let me go back to here. And instead, basically what I'm going to do is I'm going to begin the render pass using what we had basically below. So I'm just going to move that up here. So here is where we are setting up our begin info, zeroing out our memory for the clear values, setting up the clear values. We also need to do the same for depth. So we'll set the clear flags for the depth depending on what we have configured. And then we will go ahead and set our clear values to that for both the color and the clear. And then we'll begin our render pass here and update our state here. So that's one level of function that's been removed now. So that's a lot cleaner. I like that a lot better. So end render pass is actually going to wind up being simplified as well, thankfully, because there's not a whole heck of a lot to actually do here. So actually all of this, with the exception of the command buffer, can go away. Oops. So now all we need is our command buffer, and then we can call vk command and render pass, change our state, and return true, and we're done. So that's a lot cleaner. I like that a lot better. Cool. So the next thing we have is, I believe the next thing in our backend, I'm just going to move this over here. So let's see, we have our begin, our end, and then we have our newly implemented render pass get. So let's go ahead and I thought I already added this, didn't I? Yeah, I want to actually move this. I want to move this up here to next to our begin and end. So put it right there. And this is actually going to be, again, pretty similar to all the stuff that we have seen before. So first we're going to check the name to make sure that it's actually got some sort of sane value. And then we're going to do a lookup on our hash table. Again, this is all stuff we've seen before, so I'm not really going to go into it. And then we're going to bleat about it if we get an invalid ID back. Otherwise, we will go ahead and grab the registered render passes at sub ID. We'll grab the address of that and return it, and that'll give us our pointer. Okay, so the next thing that we need to do is our render target creation and destruction. And actually, for that, we can go down here, because I believe that is actually where I put all that stuff. Let's see, where was that? Yeah. So our render target create and destroy are going to be relatively simple. So the first thing that we're going to do is we're going to set up just a straight up array of attachment views. This is basically the max number of views that we could have. But what we're going to do is we're going to loop through and get our attachment count that's passed through. And we're just going to go ahead and grab our attachment's internal data casted as a Vulkan image. And then we're going to get the view of that and set attachment views sub I to that. So basically, we're just extracting the views out of our attachments. And then we're going to go ahead and take a copy of the attachments themselves and the count, because when we're actually setting this up, we can't guarantee the lifespan of those objects otherwise. And next, we'll go ahead and do our create info for our Framebuffer portion of the render target. And then, of course, we will do our vk create Framebuffer, which is the last component of that. So our Framebuffer basically will have all the information that we need to create all of that. So in this case, our attachment count, which could be 3 for our swap chain images, those are our attachments. the attachment count. Our attachments are actually here, the views of those things that we extract up here. Our width, our height, our layers is going to be 1, and then our vk create frame buffer is going to take that information and stand up our frame buffer and set it to the internal frame buffer of our out target. So that is creating a render target. It's all stuff we've seen before. It's just kind of relocated now. The destroy basically just handles the sort of opposite side of that, if you will. So all we need to do here is just slam this in. This basically looks to see if we have an internal frame buffer. We destroy it and then free its internal memory if the option to do so is free, or is flagged true rather. So we passed in our render target destroy and shutdown, we passed true here. That is why, because it actually performs a free here. We may not always want to do this. So like when we are regenerating our render targets, we actually won't want to free this internal memory because we'll want to reuse that allocation. There's no need to free it and redo it, if we're just resizing it, for example. So that is that. Okay. So the next thing that we're going to do is we're going to update our Vulkan RenderPass create. So right now this takes a whole bunch of stuff, and we actually don't need it to take all that stuff. We actually only need a few properties. So I'm actually going to just start by changing the function here, or the definition of it. So it takes a out render pass, the depth, the stencil, whether or not it has a previous pass, and whether or not it has a next pass, and that is it. So the first thing that we're going to want to change is we're going to want to set up the internal data of that, and we'll do that by allocating some space for a Vulkan render pass. We will get a pointer to that rather by cold casting it, and then we'll set the internal data to has previous and has next. We'll set those things appropriately. We will also set the internal data depth and stencil. And then, in fact, I'm actually just going to remove this code because there's enough changing here where I want to actually just, I think, regenerate it from scratch. So yeah, let's remove that. Okay. So we've copied over our internal data, depth and stencil. We are going to set up our main subpass. Again, this is all stuff that you guys have seen. It's just sort of relocated now. So we have our attachment description count. Again, this is something we'll need to come back to and make it configurable. But for right now, it is what it is. And there are several flags in our attachments that still need to be configurable as well. So the first thing that we're going to do, though, is determine whether or not we need to do the clear color on this. So if the flags for clear color buffer flag is set, then we'll need to do a clear. And that just basically has us change the load operation, whether we're going to do load operation clear or load from the previous attachment, or from the previous the results of that attachment, or the results written to that attachment from the previous render pass is what I'm trying to say. And then if we have a previous pass, then we go ahead and use color attachment optimal. Otherwise, we say it's undefined because we don't know or care what the previous layout is. If we have another render pass, we just flag that accordingly. So the final layout will either be optimal if we have another render pass, or if we don't, we're going to be presenting. Now, again, there are still some assumptions here. We're eventually probably going to be changing the way that this logic works as well. But for right now, this will work fine for the needs that we have. So the next thing that we're going to do is set up our attachment descriptions. And then we will go ahead and set up our attachment references. Right, so we have our attachment descriptions. First one is set to color attachment. We increment that. Our attachment reference is going to be the first one, so it's the first one in the array, and then the layout is going to be color attachment optimal. Our subpass information, color attachment count is going to be 1, and then we obviously have the attachment reference there. So again, this is all familiar stuff that you guys will have seen. Part of this that is maybe a little bit changed from what you've seen before is if we are clearing the depth, if that flag is set, then we are going to go ahead and have a depth attachment as well. Otherwise, we are not going to have a depth attachment, and we'll go ahead and just zero that memory out so that it doesn't think for some reason that we do. And so, again, depending on whether or not we're clearing the depth, depends on what the load operation is, whether we're just going to load it or load it and clear it. All right, the next things are actually pretty much the same as they were, so I'm not really going to go into them again. If you guys want a more in-depth description of how all this stuff works, feel free to go back to the render pass video. But basically, we set up our input, our attachments, our dependencies, and then our render pass create info, and then finally we go ahead and create our render pass. So we have this updated Vulkan render pass create here. So we actually need to go to our header file and ensure that the render pass create is up to date there as well. So we're just going to replace this guy with that. And that's a much smaller definition, which is also nice. And wait a minute, we have put this in here twice. I thought I had already put this in here. All right, so this is in here twice. We don't need it in here twice. It's already up here on line 29. So we'll get rid of that. All right, so that's render pass create. Render pass destroy is relatively simple. It's not really going to change all that much. We still need to check the render pass, but instead of checking the handle, because that's not really a thing anymore, this should actually just be render pass, and we'll name it pass. I think I did the same thing in the header file. Yeah. So now we're just dealing with a render pass object, so it should check for that, and then render pass internal data instead. And then we're going to go ahead and get the Vulkan render pass by cold casting that internal data to a Vulkan render pass pointer. Then we'll go ahead and destroy the render pass. So that should be internal data handle instead of render pass handle. And I think that is fine otherwise. We'll go ahead and zero out the internal data handle. And then also we're going to go ahead and free the internal data off of that and set it to 0 as well. So just a couple minor changes there to our Vulkan render pass destroy. Okay, so the next one is we have our Vulkan render window attachment get, and this gets by index. So the first thing that we're going to do is we're going to check to make sure that the index is not greater than or equal to the number of swap chain images we have, because that's rubbish if that's the case. So we'll check that and bleed about it and return a null pointer if somebody tries to do that, because they should be slapped. And that person will be me, so I'll be slapping myself in the future. And then we are going to return the context swap chain render textures sub index. Okay, so let me just check really quickly. Okay. All right, so that is all there is to just obtaining the window attachment. Next, we need to fill out the depth attachment. So this is actually just going to return the context swap chain depth texture. That's all that does. Just exposes that for us. And then the attachment index get is going to be the context image index casted to a U8, because that's never going to wind up being a huge number, right? I know that it's stored as a U32 because that's what Vulkan does, but we don't actually need that, so we just downcast it to a U8. Okay, I think think we're getting there. The next thing I want to take a look at is we actually deleted the regenerate frame buffers at the top, sort of the declaration of this. So we don't actually need this function anymore. That can go away. So that is gone. We do need to take a look at recreate swap chain though, because this has a couple things in it that need adjustment. So let's see, we have our swap chain recreate. We have our cached frame buffer width and height, which no longer exist. These should be context dot frame buffer width and frame buffer height. All of these can actually, I believe, be removed as well. I don't think we actually need to do this anymore. If we do, if that results in a bug, then we'll go ahead and come back and fix it. But for now, I think we're going to be fine. Okay, so we have that. We have next our frame buffers. So we actually do not want to destroy these here anymore because first off, these objects don't exist, but they're also managed elsewhere. So we don't actually want to do that. What we do want to do, though, is we want to tell the renderer that a refresh is required. So we're going to call our context on render target refresh required, which is going to refresh our render targets for us, which kind of replaces the frame buffer stuff that was there. Next, we don't have these main and UI render passes anymore, so all this stuff can go away. That will be handled by this. We also don't need this regenerate frame buffers because that is no longer going to be done as well. Let's see. So the next thing that we need to change in here is actually the last thing I believe we need to change in here is going to be shader create. Oh, is this not going to work? Oh. Shader create. Here we go. So Vulkan shader create took a render pass ID. This just needs to be updated to take a render pass pointer. So we'll just call that pass. And then what we'll do is we will get rid of this because we now have quote unquote dynamic render passes. So we don't need that hard coded logic in there anymore. And all the way down here at the bottom where we are setting our render pass here, we're just going to set, instead of out shader render pass equals render pass, we're going to set that to pass, internal data. And that should give us what we need there. So let me go ahead and build this real quick. It's probably still going to fail. Yeah, of course. So now all of our failures look to be happening on the front end, which is expected. Okay, so that is Vulkan Backend.c. So I think we are actually all good to go on that. The next thing that we probably should do, I'm thinking, is we should probably update the backend to actually hook up all those function pointers, because if we don't do that, we're going to forget to do it for sure. So let's go ahead and open render backend.c. And then right after map, texture map release resources, we're actually just going to slam in all of the changes here. So we have our render target create and destroy, and then our render pass create and destroy, render pass get, window attachment get, depth attachment get, and window attachment index get. So those things will be hooked up and ready for us on the front end. Speaking of the front end is going to need several changes itself. It should not be as much as the back end, but there still are quite a few changes that are needed. So let's go ahead and open up render frontend.h and we'll start there. So one of the things that we are going to do is, let's see, we have set view, render texture destroy. We are going to replace this renderer render pass ID. We are actually going to rename this, and we're going to say renderer render pass get. And we're just going to go ahead and accept all those changes. And this is going to just take name now. It's not going to have a out render pass ID, but it is going to return a pointer to a render pass. Okay. So that means that we actually need to change the return here from a true false to a pointer to a render pass if found, otherwise 0. And then we only take the name. We do not take the out pointer to an ID anymore. And tains, this should be a pointer to the render pass with a given name. Okay, so that's that. Renderer shader create. We've already updated this on the back end, but now we need to update it on the front end. So this is going to be render pass. We'll name this to pass, and then this will be a pointer to the render pass to be associated with the shader. So that is changed. And then let's see. So down after release resources, we're actually going to basically put in all of the front end equivalents of the back end functions that we need. So I'm going to go ahead and paste these in because I don't feel like typing all of this right now, and this video is getting long enough as it is. So we have our render target create, destroy, and then render pass create and render pass destroy. So we'll need those things from the front end. So that is all the changes that we need to do from the front end, at least the H file. So in the front end C file, we will go ahead and start at the top, and we'll work our way through this one as well. So basically, we're going to be changing up everything in here to match our new setup. So we're going to be, first off, adding a bunch of stuff to the state. So we want the renderer front end to have a little bit more responsibility over the way that some of this stuff works. So we want it to hold things like the frame buffer width and frame buffer height because it makes more sense for it to be in the front end. That's sort of agnostic of what the back end is. Here is where our world and UI render passes are going to sit. Now, these are going to be configurable via views. So really, for right now, I've just moved these pointers from the back end to the front end and changed them to the generic type. But we are going to be readdressing that in the very, very near future. So for right now, we've just removed these, but we've made it generic in the front end, or the back end rather, and we will next make it generic in the front end. We also have our render target count, how many frames we've done since a resize. So this is one thing that we're going to be doing, as we're going to be throttling the amount of resize calls that we have. We're going to do that basically by not resizing every single time we get a resize event, but we're going to wait a few frames since the last resize event to go ahead and resize. And that'll keep us from having to rebuild the swap chain too many times. Okay, so that is that. The next thing that we're going to do is probably right below the date pointer, we're going to set up a declaration for something called regenerate render targets. So this is sort of the equivalent of what used to be on the back end of regenerate frame buffers. This is regenerate render targets rather. Okay, so the next thing that we need to do is within initialize. So right after we set the state pointer, we want to go ahead and set the frame buffer width, height, whether or not we're currently resizing, and the frames since resized to 0. So this is that new resizing logic I'm talking about. We'll fill that out here in a second. Okay, so a little bit further down, we also we register for our set render mode, and then here is where we're actually going to set up our backend renderer config, because we have this critical init with our backend initialization, and now we actually need to set up our renderer backend config before we can actually set that up. So here is where we create that configuration. We set the application name. We set the function pointer to for on render target refresh required to regenerate render targets. So here is where the backend tells us, hey, you need to regenerate your render targets. this is the function that is going to do that, and we'll fill that out here in a bit. So here is our first render pass. So we're setting up our render passes. I've got a to-do in here to read this from a config file, because eventually this is not going to be hard-coded either. We are going to be creating a configuration file that will load this stuff in, and then we won't have the hard-coded sort of render passes that we have now. But basically the way that this works is we set the name, the previous name for this, since it's the first render pass, there is no previous. The next is going to be the UI render pass name. So we have the world render pass name and the UI render pass name here. These are the same as what they were before. That's important because the shader needs to know that. So we kept those same names, and then we just set them up here. We've set our render area here, our clear color here, and then our clear flags here. So this is for the first render pass. And then, of course, as you probably have surmised, we have the second render pass. And that is the UI render pass. We set the previous as world render pass. The next, there isn't one. And then the render area clear color as before, except we're not clearing anything this time. And then we go ahead and set the render config pass configs to our pass configs array. So this is just keeping us from having to dynamically allocate any memory. Okay, so the next thing that we're going to do is our critical init here is basically going to be changing a little bit. So we are initializing our backend, we're passing the renderer config, and then the address of the state pointer window render target count, and then we just output the same message as before. And then the next thing that we need to do is we actually need to go ahead and get the created render passes, because if you recall, our backend goes ahead and creates the render passes that we've passed in the config, but we don't actually have a reference here on the front end to those things yet. So we go ahead and call backend render pass get, passing the world name, set that pointer, set the render target count, and allocate some space for those targets to sit. And then we do the exact same thing for the UI render pass. Now we call our regenerate render targets. We call that manually because we've not generated it yet. Again, we'll be filling that out sometime soon. And then after that, we go ahead and put in this logic, which is should look familiar from the back end, where we set the world render pass render area for the world render pass and the UI render pass. So we go ahead and set that up. And that is all we need to do for the init for now. Now, since we've moved all that stuff to the front end, we now also have to make a change to the back end to destroy our render targets. So right before we actually shut down, we want to destroy our render targets. So we basically just loop through our render target count and destroy those render targets for each of the world passes, or for each of the render passes, world and UI targets sub I. Okay. Next, we have our renderer on resized. So this is the resize logic is going to sort of kick off here. So what we're going to do is instead of setting these here, we're actually going to nuke this and not set those here. And instead we are going to flag as resizing. So we're basically going to say, hey, we're currently resizing. Here's the new frame buffer width and height. And then we're going to reset the frames since resize back to 0. So if we are resizing, then we are going to go ahead and handle that. And then in renderer draw frame is where we're going to actually potentially handle resizing. So what we're going to do is we are going to put our new resize logic here right after we increment the frame number. So we're basically going to make sure that the window is not currently resizing. So basically, we're checking to see, hey, are we currently resizing? Increment the frames since resize, and then if 30 frames have passed since the resizing began, then we'll go ahead and update these things. So we'll set the frame buffer width and height. We'll go ahead and set the projection and UI projection. We'll go ahead and regenerate those. We will call the backend resized event, reset the frame counter, and then set the flag of resizing back to false. And so this is just a nice way for us to sort of only allow this to happen so many times. Next thing we need to do is we actually need to perform some updates on the render area for each one of these views. So here we've just got the frame buffer width and height. So those are being updated there. And then finally, we have to change our logic in here because we were taking these render pass IDs before, but we no longer have those. So the first thing that we need to do is we need to go ahead and within begin frame, if that succeeds, we go ahead and grab the attachment index. And we're going to be changing this render pass logic here, this begin render pass, to use world render pass instead, because we know that is the first one that we want to do. And then we're going to go ahead and get the world pass target at attachment index. Okay, and we're going to get the address of that so that we actually write to the correct attachment. So the next thing that we're going to do is we need to take a copy of this guy, and down here in the render pass end for world, we need to pass world render pass. All right, and next we'll need to go ahead and do the same thing for the UI. So we're going to replace this with render pass. In fact, let me get rid of this so we can see a little bit better. We're going to do that, and then we're going to take the address of state pointer UI render pass targets attachment index. All right, and we're going to take this for the end render pass and put that in here. Okay, and now that that logic is updated. The next thing that we're going to do is probably a little bit. We're going to look for that render pass ID function because that has been changed. So our render pass get rather. So we've renamed this, but we haven't actually updated the function. So this is going to take or return a render pass pointer, and it just takes a name now. And instead of doing all of this, rubbish here, all we're going to be doing is getting rid of all those hacks and just calling the backend render pass get, which is nice and simple. Cleans up the front end a little bit. All right, so the next thing is render shader create. So our backend shader create now takes a render pass pointer, and this takes a render pass pointer. So we're going to say render pass pointer pass, and then pass here, and that updates that. And the next thing that we're going to have to do is pretty much just fill out everything that we need to add at the very end of the file. So we have added our all of our functions here at the end of front end. So let's actually just grab these guys and put, front end. Put them here. Get rid of the comments because those are already in the front end. Okay. Turn these into definitions. Okay. And so we have render target create, which thankfully, because we've done all this work on the back end, is just a pass-through to the back end. The same is true with render target destroy. So that is also just a pass-through. The same is also true with render pass create. And as you probably have guessed, render pass destroy. Whoops, wrong button. So those are pretty simple. Thankfully, they are just a pass-through. So the last thing that we have to fill out is we've called this function a couple times, but we haven't actually filled it out, which is regenerate render targets. And this is actually very similar to the way that our regenerate frame buffers on the back end worked. For right now, this is just regenerating our render targets for each individual one. We probably should make this a little bit more configurable, but for right now, I'm not going to worry about that. So we're basically looping through each of the window render target count, and we are only going to destroy our world and our UI render pass. And this is because these are the only ones that are hooked to the window. So eventually we're going to want to look at that Boolean to say, hey, is this render pass is this render target actually hooked to the main Windows resize event? And if not, we won't need to do this on that. We could just perform this elsewhere. But for right now, we're just going to make this the assumption that these things need to be regenerated. So what we do is we go ahead and we destroy our render targets, but we do not destroy the internal memory. And then we go ahead and grab our attachments for that particular frame. And then we go ahead and call render target create, and we just pass through those attachments. Okay, so we have our attachments there. So the first one is for our window target texture and our depth target texture for the first one. And then this is for the second one. And we basically just set up our UI attachments. And that one only has the window target, does not have a depth attachment. Okay, so this is basically winds up being the same thing as what we had before. It's just moved and calling a different set of functions, but the functionality underlying is the same. And that is it for the renderer front end. Most of it was just callbacks to the back end. Thankfully, there's not a lot of complexity there at all. So last but not least is, I believe we actually need to make one more change to our shader system. And specifically, we're going to want to look at shader system create, because this is now going to require a render pass instead of a render pass ID to be passed through. So if we look through here, right here, so we have our render pass ID and then our render pass get. This needs to be slightly refactored. So I'm going to snip this out of here and say render pass pointer pass equals render pass get, render pass name, and we don't need the ID anymore. So we'll go ahead and get that, and then we'll say if not pass here, and then unable to find render pass. And this should be config render pass name. And that should be all we need to do for that one. And then in our shader create, we just should be able to pass. And that should be it. So let's go ahead and clean and rebuild. What did I miss? A couple things, it seems. Conflicting types for renderer shader create. Right, I did not update the front end of this. So this should be, oh, looks like I actually forgot to delete pass ID. So it had one extra parameter there. Okay, that's not a huge deal. Let's clean and build again. Conflicting types. So if shader, pass. Did I nuke? What did I nuke here? Did I nuke the wrong thing? I nuked stage count. Whoopsie. Okay. So that should be shader, pass, stage count, and that's a U8 stage count. Okay. So that should be U8 stage count. Okay. Did I do the same thing on the back end, I wonder? I might have. Let's see. Oh. Okay, I just apparently typed this backwards. Nice. And type specifier missing, defaults to int. Oh, does this need a Does that not know what render pass is? Resource types. I suppose I could just do this. Struct render pass. And then change all these to structs. It's probably going to be the same thing for render target if I had to guess. Type specifier missing. What is it saying? Oh, derp. That should be. Yeah, it wasn't that at all. That's because I'm missing a return specifier. Let me undo that. This should be. Is this a void? Or is it a B8? I don't remember. It is void. Okay. All right. We got some backend issues here. Implicit. Oh, I thought I got rid of all these. Let's see. Oh, okay. I forgot to update this function definition too in the backend. So this should be render pass pointer, and we'll just call this pass. Actually, I don't even know that I need that, but I'm going to pass it anyway. Okay. If render pass. Oh, right. This should be pass. And this should be context dot, not context arrow, because we moved that and it's no longer a pointer. All right, that built this time. I'm going to clean and rebuild just to make sure. Okay, so let's go ahead and run and see if I messed anything up. Okay, I'm seeing some errors, but it seems to be running just fine. Oh, it doesn't like the resize. Okay, so something's going on with the resize. Okay. Prior to destroying device. I'm not destroying the device though. Let me open up the oh, that may just be at the end of the log. I'm probably not destroying something somewhere. Let's see. Destroy image view. Invalid image view. Okay, so where am I destroying the image view? Should be here. So destroy image view, render textures, internal data. Let me see if there is. Oh, wait a minute. So I'm destroying the. So this is the render textures sub I, destroying the view here, but isn't the image destroy already doing that? Yeah, that's getting destroyed here. but that's just the depth texture. So that should be fine. I wonder if, all right, well, where was the other place I was doing it? Vulkan image destroy. Let's see. So this is a destruction of, let's see, what's the view here? Well, that's definitely not right. That's definitely invalid. So where is that coming from? Let's see. So we're destroying the depth texture. Did I mess something up with the depth texture? Internal data. Vulkan image destroy. I wonder if I didn't. Let me examine this object. Go here to my debug console and paste that. See what this has to say. So the memory and the view are definitely wrong. The width and height are definitely wrong. And I'll bet that maybe that handle is not right either. Okay, so when I'm creating the depth texture, allocating a new one here, Vulkan image create. So all this looks correct. Instead of going to the swap chain depth attachment, this is going directly to this image that we have here. When we set the depth texture, we are using that image. That is for create view, right? Yep, create view is true. Okay. So I guess let's put a breakpoint there and run again, because I want to see what happens when we actually create this thing. So our depth texture, actually we can inspect image here because that's our internal data. All right, that all seems to be valid. So maybe our wrap internal is busted. That was B7484. Is that the same? B7484. Okay, it is passing it correctly. So we're not registering the texture. So we are allocating a new texture. Okay. We're copying all this stuff over, setting our flags. There's our internal data getting set. And then we're returning the pointer. And now these are not correct. Am I missing something here? Why did that not? Why did that not copy that over? It should have. That is kind of bizarre. Let me put these up here in the watch window. Vulkan image pointer, image, and then Vulkan image pointer. Let's see, we want the context, swap chain, depth, texture, internal data. Wait a minute, what? Is this just wrong? Why is this getting a separate? I don't understand. Because that looks correct up in here in this watch window, but down here, when I evaluate this in real time, it's wrong. Oh, I see what I did. And I think I just found the bug, actually. Where did I get... Let's find all of these. Yep, that's why. Okay. I'm passing the address of that. I should be using it directly. Nice. I can get rid of this now. And I can get rid of this, I believe. Because now that's correct. Yep. So we should be good on that. No errors, and now we're good. So, now, let me just make sure all this stuff works. It looks good. So now we have configurable render passes, which is another step closer to our view system, which is coming very, very shortly. So, that is going to do it for this one. I know this was a little bit longer of a video, but I hope that the debugging portions of this are useful to you guys and seeing how I troubleshoot issues as I run into them. So anyway, that's going to do it for this one. Thank you guys so much for watching. If you haven't already, please consider subscribing. Hit the like button. It helps me out a lot. If you guys have any questions or comments, please leave it in the comments below. Feel free to join our Discord server as well. And I will see you guys in the next one. Thanks.